Hi, good morning. Today we are going to discuss a few problems which can be addressed using the concept of combination. So, the combination, if you have, say, n distinct objects, distinguishable objects, and if you are choosing r objects from these n distinguishable objects, then the number of ways in which we can choose r objects from n is divided by the combination and is given or represented by ncr or cnr. We use the notation ncr, and this is defined as n factorial divided by r factorial into n minus r factorial. So that's the formal definition of combination. Anyways, just clear this to make space. And we are going to solve uh, a few simple problems which can be addressed using uh, the concept of combination. So we start with question number one. A committee of 12 is to be selected from 10 men and 10 women. So there are total 10 plus 1, 20 persons, and we have to choose 12. In how many ways can the selection be carried out? If, first one, so there are no restrictions. If there is no restrictions, then we can choose 12 persons from a total of 10 plus 1, 20 persons. So it can be done in 20 C 12 different ways. And I think this expression is enough, and this can be evaluated as 20 factorial divided by, that is 1 into 2 into 3 into etc. up to 20 divided by 12 factorial into 20 minus 12, that is 8 factorial. So that's the answer. Then the second session, there must be 6 men and 6 women. So exactly 6 men and exactly 6 women. So the 6 men have to be selected from the set of 10 men, and that can be done in 10 C6 different ways, and the remaining 10 women can be selected in 10 C6 different ways. So that's the number of ways in which we can form the committee in such a way that there are exactly 6 men and 6 women. Then in case C, there must be even number of women. So the number of women in the committee can be 2, 4, then 6, 8, 10. And since there is only 10 women available, so we cannot have more than 10 persons in the committee. So we have to find out the number of ways in which we can form a committee with 2 women, 4 women, 6 women, 8 women, and 10 women. So that can be calculated as the 2 women can be selected in 10C 2 ways, and the remaining positions can be selected from men in 10C 10 ways. Then 4 women can be selected in 10C 4 ways, and the remaining 8 positions can be chosen in sorry the remaining 8 positions can be selected in 10C8 different ways, and if we are going to form a committee with 6 women, then that can be calculated or done in 10C6 into 10C 6 ways, that 6 uh, persons are men, and a committee with 8 women can be chosen in 10C8 into remaining 4 is chosen from set of all men, so 10C4 ways. Then if all are women, all 10 women are chosen, then the committee can be chosen in 10C 2 into 10c 10 different ways. And observe that uh, those are different selections, and by using the rule of sums we can have the total number of possibilities is the sum of all these combinations, and we can express this thing as uh, a summation say I varies from uh, 1 to 5, 10 c to I. When I is equal to 1 it is 2, then 4, then 6, 8. When I is equal to 5 it is 10 into 10c 12 minus 2i. So this is a simple method by which we can represent the same. Now there is question D. There must be more women than the men. That happens when, since the committee of size tall, this happens when there are at least 7 women in the committee. So we have to find out the ways in which we can choose um, a committee with 7 women, 8 women, 9 women, 10 women. Then more than 10 women is not possible because there is only 10 women. So we have to find out the number of ways in which we can form a committee with 7 women, which is to be chosen from 10. So 10c7 into 10c remaining 5 plus 10c8 into 10c4. That is how we choose 4 men into the committee. And 10c9 we choose 9 women. Then 10c3 remaining 4 men. Then 10c10 all women are included in the committee. Then the remaining 2 positions are chosen from men. So it is 10c2 ways. So that is the number of ways in which we can choose the committee with more women than men. This one also can be written as a summation, like summation 10c some k, then 10c 12 minus k, where this value of k is varying from 7, 8, 9 up to 10. So this is a method to represent the same using summation notation. And now we are moving to another question, the second one. How many arrangements of the letters in Mississippi have no consecutive uh, yes? So if you consider the word Mississippi, it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it contains n is equal to 11 letters or alphabets. Then in which we have 4s, number of s is 4. Then I is 1, 2, 3, 4, 4 i's, 4 s's, 4 i's. Then P is repeated 2 times, so 2 P's. So it is 10 letters, and remaining one is M. 1 M. So this is the combination. Now, if we consider all the letters of the word Mississippi, then the total number of arrangements, total number of arrangements is given by 11 factorial divided by 4 factorial into 4 factorial into 2 factorial into 1 factorial. This is the number of ways in which we can arrange the total letters, uh, considering the fact that 4 S are identical, 4 I's are identical, 2 P's are identical, and remaining one is a unique letter. So the letters can be arranged in 11 factorial divided by 4 factorial into 4 factorial into 2 factorial into 1 factorial different ways. Actually, we are not going to, or we are not looking at the arrangements. We are looking at the arrangements among this which has no consecutive s's. So the arrangement in which we don't have any expressions like ss. So the term Mississippi itself is not suitable or required form. Now, how we can solve it? So let us consider or construct a word just by removing all the s from the expression. So what we have is m, I, then one more I, then one more I, all these are I. Then we remove that s, 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 s. Then what remains is p, p, I. This is the remaining words. And we can arrange all these letters. Here we have 1, 2, 3, 4, 5, 6, 7, 4 plus 2, 6 plus 1, 7. 7 letters are here, and these 7 letters can be arranged in 7 factorial divided by I is repeated 4 times, so 4 factorial. P is repeated 2 times, so 2 factorial. Then m is repeated 1 time, so there is a 1 factorial which is equal to 1. So this is the number of ways in which we can arrange the letters excluding s from the word Mississippi. Now we have to insert that s in between these letters. So let us consider an arrangement m, then a preposition I, then a blank position I, and a blank position P, blank P, then blank I. Then we can add the S at the starting position as well as the ending position. So the positions in which we can add the S is 1, 2, 3, 4, 5, 6, 7, 8. So we can add the letter S at any of these 8 different positions. And we altogether has 4 S in our hand. So we have to choose 4 positions out of this 8 positions in which we have to add an S. So for example, if we choose this first 4 positions, then our word is something like S, M, S, I, S, I, S, I, P, P, I. This is a word. So in that way, we can choose 4 positions from the blank positions and attach S to that particular position in 8 C 4 different ways. So the total number of arrangements of the letters other than S is 7 factorial divided by 2 factorial into 2 factorial, and we can insert 4s in between in 8 C4 different ways so that no s come close to one another. So the total number of arrangements is 8C4 into 7 factorial divided by 4 factorial into 2 factorial. So this is the total number of arrangements in which no s are come together in the expression. So this is a funny example or an interesting example. So be familiar with this method. Now consider the collection of strings of length n, length 10, made of made up from the alphabets 0, 1, 2, and 3. How many of these strings have a weight 3? So the weight of a string is defined as the sum of letters in alphabets in it. So, for example, if you have a string of constructed using these the same set of alphabets like 1 2 1 2 1, then the weight of this string is 1 plus 2 3 plus 1 4 6 plus 1 7. So the weight is 7. So this is how we calculate the weight of a string. And here we are looking for a string which have a weight 10 and the total string is of length 10. So we have a string of length 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 10. 10 positions are there and we can arrange any of all these 10 positions can be arranged using any of the alphabet 0, 1, 2, and 3. But if the weight is equal to 3, that can happen only when either we can have 3 ones and all the remaining positions are zeros, or we can have two letters or two alphabets included in the word or string is 1 and 2 in some order, either 1 2 or 2 1 in some order, and all the remaining are zeros, or there is another possibility of having a 3 at any of the positions and all the remaining 9 positions are zeros. We get a string of weight 3 only under these three circumstances or conditions or situations. Um, so, um, first we find the number of ways in which we can choose the three positions in which we include a 1, and that three positions can be chosen in 10C three different ways. Then the single position in which a 3 can be chosen can be find in 10C1 different ways, 10C1 different ways, and all the other positions are zeros. Then here in the case of 1 or 2, say we can approach this in two different ways. Either we can choose a position first from the 10 positions for which we put a 1, and then from the remaining 9 positions we can choose a position to put the remaining number or alphabet, which is 2, or uh, we can choose two positions from 10 positions and put this element 1 2 in that position. But since we choose two positions, 1 and 2 can arrange in that two positions in two different ways, so it can be 10C2 into 2. So both will give the same result. Anyhow, this is the ways in which we can have a string of weight 3. So here we count the number of strings in which we have a given particular weight of 3. So here we go through three simple problems which can be addressed using the concept of combinations. And to familiarize with problems of counting, I recommend you to go through a number of examples, because different problems we have to address different problems in different using different strategies. So that's the only way in which we can master the concept of counting. So thank you.